Today, we will look at Charles's law. In the previous video, we considered Boyle's law. Before we go into Charles's law, click on the plus sign and give us a follow. Comment, like, and share the video. The difference between Charles's law and Boyle's law lies in what they keep constant. Remember that the following variables are very important: the pressure of the gas, the temperature of the gas, the volume, and the number of molecules. Boyle's law kept temperature constant and investigated the volume and pressure. But in Charles's law, pressure is kept constant while temperature and volume are investigated. So in 1787, Jacques Charles was investigating changes in volume of a gas and its Kelvin temperature when he kept the pressure constant. He found out what I'm going to visualize for you now. He found out that as temperature of the gas increases, the volume of the gas also increases when pressure is kept constant. And he came up with the law of volume that he called Charles's law, which states that the volume of a given mass of gas is directly proportional to its Kelvin temperature, provided that pressure remains constant. This actually represents this, because volume is directly proportional to temperature. It means that as volume increases, temperature also increases. As volume reduces, temperature also reduces. It means that graphically, when you plot volume against Kelvin temperature, you are going to get a straight line graph that begins at 0. This 0 is 0 Kelvin, and it is numerically minus 273 degrees Celsius, and it is called absolute zero. This is the graphical representation of Charles's law. If you don't want to represent it this way, you can plot the volume against Celsius temperature. And you know that the 0 here means 0 degrees Celsius and not minus 273, meaning that you are going to extend this temperature axis so that you have negative values. This is negative temperature, this is positive temperature. So because of this, the graph is not going to begin from 0 degrees Celsius. It will begin from a negative value here, 0 Kelvin, or minus 273 degrees Celsius. It's a straight line graph. It's going to make a positive intercept on V axis. And this is also Charles's law graph. This and this are the same. The difference is that this axis is temperature in Kelvin, but this axis is temperature in degrees Celsius. Now, from this statement, we are going to derive an equation known as Charles's law. We are going to remove variation sign and put a quality sign. And once we do that, we introduce a constant k before we write t. And then we make k the subject by dividing both sides by t, so that k will give us what? V over t. For initial condition of volume and temperature, we have K1 equals V1 over T1. For final condition of volume and temperature, we have K2 equals V2 over T2. K1 is a constant. It does not increase, it does not decrease. Therefore, K1 and K2 are the same. Because of that, K1 is V1 over T1. So we replace it with V1 over T1. And K2 is V2 over T2. V2 over T2. Therefore, this equation is called Charles's law. For more future chemistry videos, click on like, follow us, share this video, and subscribe to our YouTube channel. Bye.